mic was off. Okay, anyways, took a few days off. Let's try this easy. New streak. Lift square submatrix vertically. You're given an integer m by n integer. You're given m by n integer matrix grid and 3 integers x, y, k. The integers x, y represent the row and column indices of the top left corner of a square submatrix. Okay, top left. Integer k represents the size, the slide length of the square submatrix. Your task is to flip the submatrix, reversing the order of its rows and columns vertically. Reversing the order of its rows vertically. Okay. So 5, 6, 7 is the first row within the square submatrix, and it becomes 5, 6, 7 at the bottom. 9, 10, 11 stays the same. 13, 14, 15 goes to the top. Okay. I guess I probably would try just iterating through the indices and then calculating the kind of, it's doing a swap, right? So the swap, yeah, I think for swaps you always need 3 values, right? You need to have a temporary value. Okay, yeah. So, I mean, I could also create a new the question is whether or not I want to create a new grid or I want to just fill in the blank. If I fill in the blank, then I don't have to do the temporary value during the swap. Oh, okay. It's return the updated matrix, so they don't want me to create a new matrix for it. Okay. So let's go ahead and do every index within the position, right? So I think it'll be something like for every, let's say, row index, or I'll say row x for the delta x on the row in range of k, and every column x in range of k, where row x or rx is the change in the row position based on x and y being the top, index 0, 0. So at this position, you need to determine the end position, right? Or at this position being x plus rx, y plus cy, or maybe x plus I'm thinking x and y in terms of r and c actually. Okay, this might not be that kosher, but I'm gonna say r and c instead of x and y. Okay, so anyways, so the n, actually I think I only need to do the first half rows because the top row maps to the bottom row and I'm iterating over the number of rows. So I think this should be just like k divided by 2, rounded down. So at this position, which is going to be position r plus rx, c plus cx, maps to, I think it's going to be r plus k minus rx, c plus k minus cx. Let me double check that. So if r and c are at row 1, column 0, no, okay, so it's the same column position. This is just the row's position that needs to be kind of complemented. So if here this is row 1, k is 3, so 1 plus 3 is 4, minus 0 is 4. I think this should be r plus k minus 1 minus rx. Because it doesn't, r plus k would be like not inclusive of the last row index. So it should be minus 1 to be inclusive. And rx being the offset from the top position, it should be minus rx from the offset from the bottom row position. Okay, so this should be something like, let's go ahead and do a temporary value for grid at r plus rx, c plus cx. And then just store the value at the other spot. Equals grid at r plus rx, c plus cx. And then temporary is now stored into the I think that I had this reversed, right? Yeah, this is reversed. Take the other value and put it into this value that can be or restored. And then r plus k minus 1 minus 1 minus rx c plus cx is equal to grid equals temp. Alright, let's see if that works. Okay, cool. Might be a little slow, might be faster to do. Okay. I was thinking it might be faster to do some sort of it's called slice or splice. I think it's called slice. Yeah, I was thinking it might be faster to do some sort of slicing, but it's probably equivalent. Anyways, summary. Problem is mainly an exercise in proper kind of 2D matrix indexing, kind of have the appropriate nested for loop that iterates over the rows, columns, in this case the offsets to the kind of top left position, and do the appropriate swap logic on the correct positions. Make sure to get the correct kind of complementary position for any part of the square submatrix. So I'm using Rx and Cx as the offsets for the rows and columns, and then the current position is R plus Rx, C plus Cx, and then from that the complementary position that is to be swapped with is same column, since like 5 and 13, 6 and 14, 7 and 15, they're swapping the same column, but then the rows is just row plus offset is going to match with the end row minus that same offset. So r plus k minus 1 is the end row, minus Rx is the minus offset. Time complexity is going to be O of mn. What am I thinking of? I guess technically this is O of k. O of k squared. O of k squared. Since it iterates over all positions of the k square of the submatrix, which has k squared elements. Well, iterates over all slash half technically because it's only doing the top half. You don't you definitely don't want to do all the rows, since then you just re-swap into the original positioning. Space complexity could be O of 1 since this is in place. Swapping